Welcome student in my virtual class. Obviously for class 12, student of class 12. Today we start a new topic, that is differential equation, which is in your syllabus obviously. So differential equation. First we study what is differential equation, types of differential equation, and how degree and order of differential equation, and as well as how we solve the differential equation. This is the first class. So first what is differential equation, after that what is differential equation. Differential equation, first we define what is differential equation. Very easy. Differential equation is nothing but an equation which contains differential coefficient known as differential equation. A differential equation is an equation involving differential coefficient or without the variable of which this differential are derivative. Obviously derivative contains derivative. Or in other way, if we define differential equation, same things. An ordinary differential equation, first differential equation, then ordinary. Ordinary differential equation or simply differential equation is an equation involving an unknown function y of a single variable x and derivatives of y with respect to x. Derivative of y with respect to x, or other way also. So an equation which contains differential coefficient, like that. If we write dy dx is equal to sin x. This is also differential equation, since this equation contains differential coefficient dy dx, or d2y dx2 is equal to minus omega square x. Well known equation d2y dx2, or if we write d2x dt2 in variable x and t is equal to omega square x. This well-known equation of U, obviously this is equation of SAVM. d2x dt2, sorry, it is written d2x dt2 is equal to omega square x. Or if we write del y del x plus log x is equal to sin x. This is also differential equation. We take del y del x, it is partial obviously. So it is partial. So first we define differential equation, divide into two parts. One is ordinary differential equation, ODE means ordinary differential equation, and PDE means partial differential equation. Partial derivative not in our syllabus, obviously in class 12. So partial differential equation is not in our syllabus at all. Just what is differential equation, so we write partial differential equation also. Ordinary differential equation can be divided into two parts. First one is first degree ordinary differential equation. So what is ordinary differential equation? An equation which contains ordinary derivatives. That means these two are ordinary differential equation, and this is partial differential equation. We take one example of PDE, that means partial differential equation, and two examples of ordinary differential equation. If it contains ordinary derivative, then it is ordinary differential equation. If it is contain partial derivative, then it is known as partial differential equation. Now ordinary differential equation divided into two parts. First degree and higher degree. What is degree of differential equation? Define later on. First degree and higher degree. Now first degree can be divided into two parts also. One is first order, another is higher order. First order and higher order. Sorry, it is not for that. It is for this one. Now, first order, first degree. Ordinary differential equation, first order, first degree into four. There are four types. One is separation of variable. Number 2 is homogeneous, number 3 is exact, and number 4 is linear. Four types of differential equation of first order, first degree. Ordinary differential equation of first order, first degree is separation of variable, homogeneous, exact and linear. And higher degree, this can be broken in three parts obviously, solved for x, solved for y and Clairaut's equation Obviously there are so many parts of this one also, higher order also as this one, homogeneous, exact, linear also in higher order also, but we are not interested on that. We are not interested on that also. In our syllabus only this portion we have to solve these four types of equation. In our syllabus we are interested only on these four types of equation which have to solve our. So differential equation can be divided first ordinary and partial. It is known to all of us now. For ordinary differential equation it contains ordinary derivative, and partial differential equation for partial derivative. Now this is the first degree and higher degree, first one. Then first order, higher order. So what is the degree and order of differential equation? It is very interesting problem, and not only that, for degree and order is very important for MCQ question also, not only in HS. It is one problem in all the question of JEE mains etc. or West Bengal Joint, find the order and degree. So we discuss order and degree of differential equation and formation of differential equation. Okay. Order and degree of differential equation. Order is very easy, no problem at all. The order of a differential equation is the highest order derivative involved in the equation. Here D means differential equation. In this case we have mentioned D means ordinary differential equation also, not ODE. I write D because only the ordinary differential equation in our syllabus. So the differential equation means ordinary differential equation. Okay, not mentioned later on. So order of differential equation is the highest order derivative involved in the equation. The order of differential equation is the highest order derivative involved in the equation. So study this equation. We take few examples. So what is the order? Then we go to the degree. First order. So highest order derivative present in the equation or involved in the equation known as its order. So the first equation d2y dx2 plus x plus dy dx plus y is equal to 0. So highest order derivative present here, the second order. Therefore order of this equation is how much? Obviously it is order is 2. Order of this equation is 2. In the second case, derivative involves in the second equation d2y dx3 whole cube plus 3 dy dx plus y is equal to 0. So obviously order of this equation is highest order derivative present in this equation is 2. So order is also order is also 2. Order is 2. And the third equation, similarly, third equation is also order, highest order derivative present here is second order, this is first order, so order is again 2. This one 1 plus d2y dx2 whole to the power 3 by 2 is equal to c into d2y dx2. In this case this is also second order derivative, this is also second order derivative, so order of this differential equation, order is 2. Here in the last equation here the order of derivative, highest order of derivative, this is dy dx, this is d2y dx2 and this is d3y dx3. So order of this differential equation must be how much? Order of this equation is 3 since it contains third order derivative. So another, if we take another example if we take another example, say dy dx plus y by x is equal to 1. Y by x is equal to 1. So in this case dy dx plus y by x is equal to 1. So highest order derivative present here, here is 1. So order is 1, first order. So order is very clear. Highest order derivative present or involved in the equation known as its order. But degree of differential equation, first we define the degree of differential equation of which the differential coefficient, this is differential coefficient, are free from radicals or fraction is the positive integral power of highest power of the highest order derivatives involved. The degree of a differential equation of which the differential coefficient are free from radical sign and fraction is the positive integral index of the highest power of the highest order derivative involves. Or in other way we can conclude, if the differential equation is expressed as a polynomial in the derivatives, then the highest positive integral index or highest power, both are same, of a highest order derivative involved in the differential equation is its degree of the differential equation. So next we study about its degree. First one, dy dx is equal to y by x plus 1. So its order is 1, already written. So power of dy dx here, power of dy dx highest is also 1. So degree is also 1. Order is 1, degree of the first equation is also 1. In the second case, d2y dx2 plus x whole square. Now if we squaring this, then we get dy dx d2y dx2 whole square. So maximum power of highest order derivative involved here, that is d2y dx2, its power is 2. So degree is also 2. Third one, d2y dx3 whole cube plus 3 dy dx plus y. So in this case, so highest power of highest order derivative is 3. So degree of this differential equation is 3. Next question, x into d2y dx2 whole square plus x square dy dx whole to the power 4 plus x cube is equal to 0. Here we see that this is highest dy dx whole to the power 4 and d2y dx2 whole to the power 3, but from our definition, highest order derivative, powers of highest order derivative, positive integral power of highest order derivative. Okay, so highest order derivative is this one. So integral power of this is 3. So our degree of this differential equation is 3, not 4. Degree of this differential equation is 3, not 4. Since it is the first order derivative, it is the second order derivative. So powers of second order derivative. So degree of this differential equation is 3. Next, question number 4. It is 1 plus d2y dx2 whole to the power 3 by 2 is equal to c into d2y dx2. Here you see that powers of this is 1 and powers of this is 3 by 2. But in our definition, free from radicals and fraction or and it may be or fraction. So this is the radical sign, square root 3 by 2. So we must express it into integral power, positive integral power. So if we squaring this on both sides, then we get how much? 1 plus d2y dx2 whole to the power 3. If we squaring this, then we get c into d2y dx2 whole to the power c into this whole to the power 2. Squaring both sides, we get this. Now what happened after that? So this is integral power, positive integral, this is positive integral power. Now if we cubing both sides, this is cube 3. So if we break it in this way, a plus b whole cube formula, then you get d2y dx3 whole to the power 3. d2y dx3 whole to the power 3, and here we get d2y dx2 whole to the power 2. So highest power of the derivative is 3. So degree of this differential equation is 3, not 3 by 2. First free from radical sign, then we write. And the last question, e to the power dy dx plus sin x d2y dx2 plus cos d3y dx3 plus 7xy is equal to 0. Order of this differential equation is 3, but what is the degree? In this case, this cannot be written in the polynomial form of the derivatives, that is d2y dx2, dy dx or d3y dx3. It can never written in the polynomial powers, in form of polynomial of the derivatives. That means degree cannot be determined. Degree of this differential equation cannot be determined. That means degree, this has no degree. This differential equation has no degree. Okay, this differential equation has no degree. That means order of differential equation are always valid, but degree of differential equation, it may or may not be determined. Sometimes degree is not determined. So this type of equation has no degree, since it can be written in the form of polynomial form of the derivatives, then we determine the degree. Otherwise degree cannot be determined, no degree. Clear? So this is the degree and order of differential equation. Next we start formation of differential equation. Obviously ordinary differential equation, I repeat once again. Here we write 3 questions, 1, 2 and 3. First one, find the differential equation of all straight line pass through origin. All straight line passes through origin. So equation of straight line pass through origin, that means constant term must be 0. If we take in general form ax plus by plus c, here c is 0, ax plus by is equal to 0, then we can write y is equal to minus of a by bx in this form. So we take slope form. Intercept is 0 since it passed through origin. Equation of straight line, if you take y is equal to a plus, if we take this one ax plus by is equal to 0, no problem at all, then we can also write y is equal to minus of a by b into x. So instead of m, this is minus of a by b. So first we write y is equal to mx, no problem. So here m is the slope, in this case a by b minus a by b is the slope. So that is nothing but, that is m is the arbitrary constant. If slope is changed, then we get the straight line will be changed. Slope will be changed, then we get different straight line. So in this case arbitrary constant is m. If an equation contain arbitrary constant, only one arbitrary constant, then the differential equation must be first order. If an equation contain two arbitrary constant, then the equation must be second order. If an equation contain three arbitrary constant, then the differential equation must be third order, and so on. Okay, so we have to eliminate m. So how we eliminate m here? M is the slope. So differentiating both sides with respect to x. So y, differentiate from y dy dx, and differentiation of mx, that is nothing but m, since differentiation of x is 1 and m is constant. So m is equal to dy dx. M is nothing but dy dx, and we have to replace m, eliminate m from these two. So instead of m, we can write here dy dx. So from equation 1 and 2 we can write y is equal to m, instead of m we write dy dx, and x remains same. So y is equal to x into dy dx. This is the required differential equation, or you may write in this way, dy dx is equal to y by x. This is the required differential equation. This is question number 1. Okay, next we start question number 2. Given that v is equal to a by r plus b satisfy the differential equation d2v dr2 plus 2 by r dv dr is equal to 0. This is the differential equation. This is free from the arbitrary constant a and b. So here the two different arbitrary constant and these are a and b. So we have to eliminate a and b. This is the just formation of differential equation is this type of problem here we have already done in second order derivative problem. Okay. In second order derivative we solve this type of problem. On this case, given v is equal to this, then prove that in second order derivative. So just like this one, v is equal to a by r plus b, differentiating both sides with respect to x, the derivative of b is dv dr, and this is 1 by r, derivative of 1 by r with respect to r is minus 1 by, just like this, dx of 1 by x is minus 1 by x square. It is known to all of us. So ddx of 1 by x is minus 1 by x square. So ddr of 1 by r is minus 1 by r square, and derivative of constant quantity is 0. So this is absent. Or we can write r square multiplying on both sides. R square dv dr is equal to minus a. Again differentiating both sides with respect to r. So if we differentiate this, r square remains same, then ddr of dv dr. That means we get d2v dr2, very easy, and dv dr remain unchanged, derivative of r square, that is 2r with respect to r, so we get 2r, and derivative of constant quantity, that is a, is 0. So we can write r square d2v dr2 plus twice r dv dr is equal to 0. Now dividing both sides by r square, then you get d2v dr2 plus 2 by r dv dr is equal to 0. Okay, this is the problem number 2. And problem number 3, obtain a differential equation of all straight lines which are at fixed distance p from the origin. Obtain a differential equation of all straight lines which are at fixed distance p from the origin. That means we have to find out the differential equation of all straight lines whose distance from origin is p. Okay, so do it now. Try it yourself and send it to me after the class. After the class you send it to me. It is for your class work. Okay. Solve differential equation by separation of variable. First order, first degree. So how we solve the differential equation of first is separation of variable, then homogeneous, exact, etc. First today we separation of variable start. The equation mdx plus ndy is equal to 0 can be put in the form of f1x dx plus f2y dy is equal to 0. Then it can be solved by integrating each term separately. That means first with dx we get the function of x, and with dy we take the function of y. Then just integrate separately, we get the answer. Then integration is possible if we replace this with x dx and with the function of y dy. So first question, for easy solve this in this way. First problem, we take 1 plus y square into dx plus 1 plus x square into dy is equal to 0. So in this case we see that this is 1 plus y square with dx, this is function of y, and 1 plus x square with dy, this is function of x, just difference. If it is in reverse way, then we can easily integrate and solve it. So first, in this way, if you just overcome this problem, we divide both sides by 1 plus x square and 1 plus y square. So if we divide this 1 plus x square into 1 plus y square, we get 1 plus x square, 1 plus y square cancel out, and the second one we get 1 plus y square. So first one dx by 1 plus x square, this is function of x only, and dy by 1 plus y square, this is function of y only. So integrating both sides, So dx by 1 plus x square, dy by 1 plus y square, that is equals to c, and we know that the formula dx by 1 plus x square is nothing but tan inverse 6. Integration of dx by 1 plus x square is nothing but tan inverse 6. It is known to all of you. So use the integration formula. Dx by 1 plus x square is equal to tan inverse 6, and dy by 1 plus y square, we write tan inverse y, that is c. If you take tan inverse 6 plus, you know the formula of tan inverse 6 plus tan inverse y, then it is simplification maybe. But up to this, if you do this problem in this way, no problem at all, you get full credit. Okay. Next, second question. Sec square x into tan y into dx. Sec square y into tan x dy is equal to 0. So here is the same problem. If tan y is not present here and tan x is not present here, then we get the answer very easily. Integrating both sides, we get the answer. So overcome this, we take into right hand side. Sec square y into tan x into right hand side. Now after this tan y goes there and tan x go here. So sec square x by tan x dx, and this is sec square y by tan y dy. So obviously this is the function of x only, and this is the function of y only. This is the function of x only, and this is the function of y only. Then we integrate this. After integrating, we get the result. So for integrating, put first one tan x is equal to u. So derivative of tan x is very known, well known, sec square x. So sec square x dx is equal to du. And if we substitute this, tan y is equal to v, then sec square y dy is equal to dv. Sec square y dy is equal to dv. Putting this. So after this, we can write here du by u, first one, sec square x dx is equal to du and tan x is u. So du by u is equal to minus of dv by v. So du by u, integrating, we get log u. So log u is equal to minus of log v. Instead of c, here we take constant is log c, no problem at all. If you write log c, then c must be greater than 0, you must, right? Since c is equal to 0, then it is undefined and is negative, log is not valid. So for any integrating this log function, always we take mod value. So take it into left hand side and use the property of logarithm. Log u plus log v, that is log of uv is equal to log c, taking anti-log. That means we can write uv is equal to c, or put the value of u and v. U is nothing but tan x and v is nothing but tan but tan y. So tan x tan y is equal to c. This is the answer. Next, I give another two questions to solve. Number 1 and 2, x square into x dx plus y dy plus 2y into x dy minus y dx is equal to 0. And number 2, x plus y1, y1 is nothing but dy dx, y1 is nothing but dy dx, divided by xy1 minus y, xy1 minus y is equal to root over of 1 minus x square minus y square by x square plus y square. So after watching this, you try to solve these two problems and send it to me in my number. Okay, after this, watching this video, you may send it. For hint of these two, use polar coordinates. Hint is given, then try yourself. Cartesian to polar, you go polar and solve it. And from nearer these two problems. Okay, write down these two problems and send it to me. Okay, it's clear now. Thank you.